Hi guys, welcome to the SIT IT program here on YouTube. This is one of several video tutorial clips that we're going to be producing and posting for students. So today we're going to look at number systems and number conversions. And so we'll start off with a quick discussion about number systems just as a recap for our little review. And then we'll look at doing number conversions both from decimal to binary and also from binary to decimal. Because these both are very important to be able to do for our later stuff that we're going to look at with subnetting and in just handling IP addresses in general. So to start with, we can start looking at number systems in general. And in particular, the number system that we're most familiar with, the decimal number system, or as we can also refer to it, the base 10 number system. Now base 10, that terminology is important because that's going to relate to how we go about converting between binary and decimal. And what it means, if we take as an example the number 138. If we take a quick look at the actual structure of that number, what it really actually means is 100 plus 30 plus 8. Each of those individual digits has a particular value, and the value is actually a weighted value. The entire number is a weighted sum of its digits. Each position has a particular weight attached to it. By multiplying the digit by the weight of the position, we get the total value of the numbers. What we mean by that, I can think of each of those digit positions as having a particular weight. Now, in decimal, the weights are 1, 10, 100. If I continue going to the left, I'm going to continue increasing those weights in the same way. The next one will be 1,000, 10,000, 100,000, so on and so forth. So this is where we get 1 times 100, 3 times 10, 8 times 1, giving us 138. Another way we can look at that, though, is to look at where we get these from. Those weight values are based on the base that we're using to a particular exponent. One is actually 10 to an exponent, 10 to an exponent, 10 to an exponent. The first position, 10 to the power of 0. Next one, 10 to the power of 1, 10 to the power of 2. And that exponent just simply increases as we go to the digits to the left. And that is how any number system works as far as its underlying structure. The base of the number system to some exponent for each individual digit. Multiply the digit by the weight of its position, add everything up, and that gives you the value. So if that's base 10, we can do the exact same thing for binary. We'll say a 4-bit number, a 4-bit binary number. Each of those positions has a particular weight. And it works exactly like this. The only difference is instead of 10 to some exponent, it's 2 to some exponent. Because now, instead of base 10, binary is base 2. So we can write that out in that way. Or I can also do the same thing and say that 2 to the power of 0 is 1, 2 to the power of 1 pardon me, is 2. 2 squared is 4. 2 cubed is 8. So for any binary number, I simply take the digits for each position, multiply the digits by their corresponding weight, add them up, and I have what that binary number is in decimal. And this works for any number system. So for example, if I wanted to look at, say, 1001, that particular binary number. To figure it out, I simply multiply each of these times its weight, add them up, and that gives me the equivalent in decimal. So 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. If I add all that up, what I get is 9. So 1001 in binary equals 9 in decimal. And that's how we do the conversion between binary numbers to decimal numbers. And we can look at another example of this. For example, 1101 we'll say. So 1101 in binary, to convert it to decimal, write out the weights, multiply each digit by its corresponding weight, add them up, and that gives us the decimal. So 1 times 8 is 8, 1 times 4, 4, 0 times 2, 0, 1 times 1, 1. And that equals 13 in decimal. So 1101 in binary is decimal 13. And that's how we can do any conversion from binary into decimal. Now in doing conversions, we'll do a couple more examples of longer binary numbers, like what we would see when we're working with IP addresses, because IP address numbers are going to be 8-bit octets, not 4-bit numbers. So we'll look at a couple of longer examples. But one thing we can do, and this is a good habit to get into, especially when you're first learning this, because it's very, very easy to make mistakes with these.